this particular video, what I'm going to do is quickly review what we did in class about special right triangles and how to find the trig ratios using those special right triangles. So if you recall from class, we first looked at the 30, 60, 90 triangle. Again, you all know that I do beautiful triangles. Okay, so we have 60 degrees and 30 degrees. That's supposed to be a 3. And this is the 90 degree. This one's always 2x. The shorter leg is x. The longer leg is x radical 3. Now this is supposed to be a shorter leg than this one, but I hope you understand from my drawing. Now, let's find some trig ratios. So let's work with the 30 degree one first. If we were to find the sine of 30 degrees, remember, we looked at SOHCAHTOA, so we're going to do SOHCAHTOA. That's a good way of remembering the trig ratios. The S stands for sine, the O stands for opposite, H hypotenuse, and then cosine is adjacent over hypotenuse. Then we have tangent is opposite over adjacent. So the sine of 30 is OH, so opposite over hypotenuse. So if we look at 30, opposite is x, and hypotenuse is 2x. So we have x over 2x. The x's cancel. So we're left with 1 over 2. There's nothing left in the numerator, so we put a 1. And we have a 2 left in the denominator. Cosine of 30 degrees is adjacent over hypotenuse. So 30 adjacent is x radical 3 over hypotenuse, 2x. The hypotenuse is also adjacent to 30, but when we say adjacent, we refer to the side that's not the hypotenuse. The x's cancel, and we're left with radical 3 over 2. Then, so the x is canceled. Then we are going to do the tangent of 30. Tangent is opposite over adjacent, OA. So the tangent of 30 opposite is x, adjacent is x radical 3. The x's cancel, we're left with 1 over radical 3. Well, you can't leave that as 1 over radical 3. You have to rationalize. So we multiply the numerator and the denominator by radical 3, and we get radical 3 over 3. Because radical 3 times radical 3, since the same number's inside, the radicals cancel. Now let's work with the sine of 60 degrees. Okay, this thing goes nice and fast. Having technical difficulties with this. Okay, so we're looking for the sine of 60 degrees. Any time now. OMG. Okay, I don't want to waste time with that. The sine of 60 degrees is equal to opposite over hypotenuse. So 60, opposite is x radical 3 over hypotenuse, 2x. The x's cancel, so we're left with radical 3 over 2. Now let's do the cosine. I'm going to go ahead and erase our little SOHCAHTOA symbols or acronyms. And we're going to calculate the cosine of 16. That's adjacent, which is x, over hypotenuse, 2x. The x's cancel, and we're left with 1/2. Then the tangent of 16. Opposite over adjacent. Opposite over adjacent. So it's x radical 3 over x. The x's cancel, and we're left with radical 3. And that's it for the 30, 60, 90 triangle. Now, notice the x is always canceled. So what that tells us is that the side lengths of triangles don't really matter. No matter how big or how small a triangle is, you always get the same ratio. So the sine of 30 is always 1/2, no matter what type of triangle or how big the triangle is. As long as it has a 30 degree in it, the sine of that 30 degree is going to be 1/2. The cosine of 30 is always going to be radical 3 over 2. The tangent of 30 is always going to be radical 3 over 3. And the sine of 60 is always going to be radical 3 over 2. Now, it's useful to memorize these because when you work problems out in the future, you're going to be able to work them out quickly when you know this by memory. Now, let's look at this 45, 45, 90 triangle. That's the other one you should have be pretty familiar with. So we have 45, 45, 90. Recall the hypotenuse is always x radical 2. The side lengths are always x. So let's figure out what the sine of 45 is. Well, sine is opposite over hypotenuse. So 45, opposite is x, and hypotenuse is x radical 2. So x over x radical 2. The x's cancel, and you're left with 1 over radical 2. Now, we can't leave it as 1 over radical 2. We have to rationalize it. So 1 over radical 2, you have to multiply the numerator and the denominator by radical 2, and you get radical 2 over 2. And that's your final answer. So the sine of 45 is equal to radical 2 over 2. Now let's look at the cosine of 45. Cosine is adjacent over hypotenuse, which happens to be the same as the sine. We got x over x radical 2. The x's cancel again. And we don't have to work it out a second time because we already did the work up here. So that equals radical 2 over 2. And finally, we're going to look at the tangent of 45 degrees. That's opposite over adjacent. So opposite over adjacent, x over x. That equals 1. No matter how big or small a 45, 45, 90 triangle is, your sine of 45 is always going to be radical 2 over 2. Your cosine of 45 is always going to be radical 2 over 2. And your tangent of 45 is always going to be 1. So I hope this helps you with your basic trig functions, 30, 60, and 45. We also did in class a little handy observation. The sine of 90 degrees, well, sine is opposite over hypotenuse. So what's opposite the 90 degree angle? That's right, x radical 2. So opposite over hypotenuse. Well, the hypotenuse is still x radical 2. So x radical 2 over x radical 2 is just 1. So the sine of 90 is always 1. We're not going to go into the cosine of 90 or the tangent of 90 yet. You learned that later on. If you notice here, we can't do the cosine of 90 because both of these sides are adjacent, and cosine is adjacent. So we wouldn't know which one to use. So cosine of 90 does not exist right now. All right, and I hope that helped you.